Good evening, everyone. Welcome to the University Club. We are really excited to be back in Chicago after 2 years to host this critical conversation. My name is Madhu Khanna. I'm the Alvin H. Baum Family Chair and Director of the Institute for Sustainability, Energy and Environment, or iSEE, that is hosting this event. We're at the University of Illinois Urbana-Champaign campus. As a land-grant institution, our campus has a responsibility to acknowledge the historical context in which we exist. We're currently on the lands of the Peoria, Kaskaskia, Piankashaw, Wea, Miami, Mascoutin, Odawa, Sauk, Meskwaki, Kickapoo, Potawatomi, Ojibwe, and Chickasaw nations. It is necessary for us to acknowledge these Native nations and for us to work with them as we move forward as an institution with Native people at the core of our efforts. We're really pleased to be able to host this critical conversation focused on climate insecurities in the Great Lakes region this year. This is the fourth critical conversation that iSEE is organizing. iSEE is an institute that was founded in 2013. And one of its missions is to generate critical thinking and productive conversations around wicked sustainability challenges, such as the one we're talking about today, in the general area of energy and environmental and social problems. We regularly bring national and international scientists, activists, policymakers, and others together to provoke thoughtful discourse. And we thank you all for joining us today to talk about the challenges facing the Great Lakes region with this changing climate and measures that we can take to adapt to them. We're really delighted to have with us the University of Illinois System President, Tim Killeen, to deliver opening remarks today. I'll briefly introduce Professor Killeen. Professor Killeen is the 20th president of the University of Illinois System with campuses in Urbana-Champaign, Chicago, and Springfield. He's a leading researcher in geophysics and space sciences, a member of the National Academy of Engineering, a member and past president of the American Geophysical Union, and a fellow of the American Meteorological Society and the American Association for the Advancement of Science. He's a strong supporter of sustainability initiatives across the University of Illinois system and beyond. As an atmospheric researcher, President Killeen is keenly aware of the effects of climate change worldwide and here in the Midwest. He has led to the creation of 2 pioneering new initiatives to drive innovation and workforce development: the Discovery Partners Institute, a world-class research center in downtown Chicago, and the Illinois Innovation Network, a network of all state universities working together to drive innovation along with economic workforce and workforce development across Illinois. President Killeen, together with the president of the University of Toronto, has co-founded the Great Lakes Higher Education Consortium with the goal of providing a unique platform for higher education institutions to connect across borders on a range of regionally significant socioeconomic and environmental issues. The consortium has now expanded to include 4 other partner institutions, including the Queens and McGill University in Canada and the Universities of Michigan and Wisconsin in the US. And we're really grateful for the funding provided by GLHEC for this critical conversation, as well as to the Alvin H. Baum Family Fund for their support for the Critical Conversation series in iSEE. Please join me in welcoming President Killeen to give some opening remarks.
Thank you, Dr. Khanna, for the kind and warm welcome, and it's great to see you all here. Yes, I'm the president of the University of Illinois System. We have 95,000 students, thousands of faculty, a lot of research that's directly relevant to what's going on here. And I was a former assistant director at NSF as well, where we had the earth, fire, water, severe impacts, and climate change as well. So I'm kind of personally committed to this field and to the importance of what you're all working on. So thank you for coming. I'm really honored to join you and talk about, just briefly, 2 critical challenges in our world and our region: climate change and social injustice. And notice I don't say social justice, because I think we need to grapple with both of those. They're inextricably intertwined. So it's right that we're here not only to identify and have conversations about specific challenges like water quality, land conservation, biodiversity, richness, etc., but to move forward with ideas that will bring about positive change for already vulnerable communities in our region. And I really strongly believe that universities working with private partners and governmental partners can really make a difference if they really focus intensively and intentionally on these challenges. And we can only make progress by devoting attention to the very real climate challenges that will add even more burdens to indigenous peoples and other marginalized groups. And this binational effort of Canada and the United States, I believe, is critical, and we're just getting started on it. The Great Lakes Higher Education Consortium, or GLHEC, is administered by the Council for the Great Lakes region, but it was indeed co-founded by the University of Illinois System and University of Toronto in October 2020, and it's already expanded with funding from the State Department and others, and it's great that it's sponsoring this current workshop. It formed so that compassionate and passionate experts from institutions, capable institutions of higher learning, can engage in cross-border collaborations with companies and the government to promote sustainability, build a pipeline of talent and innovation, and improve the region's long-term competitiveness. This region has everything. It has the world cities, it has rural regions, it has erstwhile towns that had manufacturing bases, it's got indigenous populations, and it's got declining Great Lakes as well that we really need to take care of with stewardship. At our universities and in this consortium, elevating diverse voices is essential. And we do have much to learn from indigenous groups' ingrained commitment to protecting our earth and its natural resources. And as we listen and learn together, we can forge a brighter path forward by making sure we respectfully collect and use such knowledge from the peoples of the Great Lakes area's cultures. We will learn more about the place-based nature of these groups, how the water and wildlife around them drives their lives and livelihoods. And already we're partnering to address gaps in our knowledge about climate change at spatial and temporal resolution of value to decision makers at all regions. And the impact on species loss, as well as to how to adapt to less predictable seasonal patterns and varied and more severe weather events. And as somebody who taught weather and climate for must have been 35 years or so, we're just a 2 sigma summer away from people freaking out about the importance of climate change on the world. And so we need to build our capacity now, intellectual and through partnerships, to make sure that we're ready to provide the kinds of solutions that are going to be needed for adaptation, mitigation, and just taking care of our communities. The shift to a more holistic, but yet science-based approach will reap benefits for the Great Lakes region and beyond. I think we can model for the world what can be really done when you combine the resources that we have to hand. And I include in that more bandwidth than anywhere else, supercomputers, high resolution, spatially resolving, convection resolving, modeling of scenarios into the future, and the social science, behavioral science, and yes, the ethicists and the historians that are going to be really needed to weave solutions together. In urban areas, often populated by people of color who have been underrepresented for generations, we have in Chicago sewer and stormwater issues that thwart access to clean, safe, and affordable drinking water. This is on our watch in 2022. So we feel a serious responsibility at the University of Illinois System to actually provide direct solutions for these kinds of things. Climate change and drought will only exacerbate these problems and lead to greater disparities in life expectancy across this city and up and down the state that are problems that are worthy of our consideration and solutions. We know that people who live in poverty don't often get enough seats at the table to share their experiences and be part of our solutions. And the innovation systems that Madhu talked about, the Discovery Partners Institute and the Illinois Innovation Network, are designed to be inclusive from the get-go. So yes, it's going to be about IPOs and billionaires, but it's going to be very much about social equity and not leaving communities and peoples behind. That has been done systemically over many years. So we must take seriously our obligation to work at every opportunity and move the needle to reduce and remove barriers that poverty places on individuals and families. That's occurring in Canada as well as America. Those talent pipelines are very important for us to foster so that particularly youth can see hope and opportunity, and they can have access to direct experiential opportunities that bring them forward into civil society more effectively than at present. And these will lead to jobs and reduce tension in cities and the kinds of societal issues that seem to be chronic in many locations. So climate changes in the Great Lakes region is the place to really begin. And perhaps this region can be the capital of solutions for planet Earth if we work well together collectively. We have institutions that are research powerhouses. We have Department of Energy labs. We have municipal and governmental entities that have strong interests in working together. And we have this binational partnership that I'm very excited about. It will grow over time, but we need success to breed success as we move forward, working on all kinds of issues, obviously in cities, but abating algal blooms in Lake Erie, for example, that we've all seen from space, planning for and coping with the rising summer temperatures, dangerous for the elderly and infirm, repairing damage to coastlines larger than the U.S. East and West coasts combined in the Great Lakes region. So we have a significant coastline issue. And then, of course, dramatically reducing greenhouse gas emissions from a host of sources. So the world is to be invented. I think it was Abraham Lincoln who said that something good about predicting the future. You actually make the future, you design it, and then you implement the future. And I think that is the responsibility we all have, and you all have as well, as leaders in your respective institutions. So you can tell I'm a little bit passionate about this field. I apologize for that. Normally they wheelbarrow me in as the university president, and I'm very good with recognizing individuals. So it's great to have this event occurring here. So thank you again. I'd be remiss, though, without some key recognitions, and so many have made this week's gathering possible. The United States mission in Canada allows GLHEC to do so much more than to merely exist as a box to be checked. With its funding and support, we can indeed make impactful changes for a more equitable and sustainable work, and we're just starting. Thank you to the GLHEC for your ongoing commitment and your help in making this event possible. Thank you also to our main event sponsor, the Alvin H. Baum Family Fund, the founding benefactor of the Institute for Sustainability, Energy and Environment, known as iSEE, which I like that acronym. What do you see? You see everything, right? Also to the Critical Conversation Organizing Committee that includes scholars from UIUC and from universities in Canada, including Windsor, McGill, and Toronto. Kudos to the iSEE staff for organizing this event and raising awareness of these critical tandem issues. We could not enact positive movement around climate change and social injustice without the caring and skillful administration of the Baum Family Fund by Joel Friedman and Loretta Namovic. Our profound gratitude to Joel for generously supporting iSEE and this critical conversation series. So I look forward to hearing about the panels and conversations tomorrow and tonight that will bring together great minds committed to working together in a generous collaborative spirit to actually take on and solve some of these great challenges. Together we will facilitate progress on the complex, Madhu called the wicked challenges, pressing socioeconomic and environmental pressures on our shared Great Lakes region. And in so doing, we can be a model for the rest of the world. We will further unite groups with the shared desire and drive to ensure that insecurities due to climate change remain at the forefront and are addressed carefully. And we will ensure that our actionable research and stakeholder interactions are inclusive of marginalized peoples and cultures for their brightest possible futures. Thank you all for being here and participating fully in our important work. Thank you for inviting me to make some welcoming remarks. And now I'll hand the podium back to Dr. Khanna.
Dr. Béland's involvement in Great Lake issues came from his past work as a scientist in environmental ecology and work on the impact of toxic man-made chemicals in the Great Lakes St. Lawrence food chains. He has published books and numerous scientific and popular articles, hosted a TV series on the environment, and participated in several documentary films. He's also chaired public hearings for various agencies, such as the Quebec Environmental Hearings Board, Parks Canada, Fisheries and Oceans Canada, and the Quebec Energy Efficiency Agency. He's previously headed the Fisheries Ecology Research Center with the Department of Fisheries and Oceans in Canada and was a paleoecologist with the National Museum of Nature. From 95 to 98, he was the IGC commissioner and led the remedial action plans for areas of concern in the Great Lakes St. Lawrence Basin. He holds a PhD in marine sciences from Dalhousie University in Halifax, Nova Scotia. As a binational institution, the IJC has a unique role in assisting the governments with the oversight of US-Canada boundary waters, their levels and flows, water quality, and aquatic ecosystem health. Since these lakes and rivers and their watersheds represent a significant percentage of continental water supplies, they offer an opportunity for the development of broad management models in response to climate change. When the IGC undertakes studies at the request of the two governments, it brings together representatives from various levels of government, local interests, communities, and indigenous people. And so Dr. Béland is really well suited to talk to us today about climate insecurities in the Great Lakes. And he's going to talk about the insights from across the US-Canada transboundary. He's going to discuss practices that are adaptive to changing conditions and fluctuating water regimes, which will inform our actions as global climate change plays out locally. We're really excited to have him with us. Please join me in welcoming Dr. Béland.
Thank you. Good evening, and thank you for having me. I'm looking for my text now. With you tonight. I'm so happy to be back in Chicago. I have not been here in a while. My favorite city in America, and I've been here very often and always enjoy it. Thank you, Tim. And he said there would be great minds. You will see them tomorrow. My intent tonight is to contribute to 3 of the stated goals for this event. I've chosen those: informing existing interests, answering to insecurities among communities, and how the institutions and the public are to be valued in responding to challenges imposed by climate change. Even those 3 are a huge task in a huge field, so I've had to make choices, and I will address the following themes as viewed in relation to the mandate of the International Joint Commission. Our actions must be based on verifiable facts and a scientific approach. We must look to the future, working from trends and trajectories from what we have learned that can be of use elsewhere. We need to reduce the still unknowns when it comes to the timing, the duration, and the severity of climate change manifestations. We must be committed to public engagement and the sharing of knowledge. And I like to say that knowledge that is not shared is useless. You may have found a cure for cancer, but if you don't tell anybody, it will not be of use. Convene responsible entities and stakeholders to collaboratively chart a path forward. Be inclusive, and Tim mentioned that, working with indigenous communities, the vulnerable, the marginalized, all must be heard and considered. My first part of my lecture today will be about the IJC and its mandate, so you know how I refer every of the elements I will be talking about tonight. So the IJC is an impressive, and I'm very honored to be part of the IJC, a venerable and unique institution that originated from a treaty between Canada and the United States of America. Unlike other international bodies overseeing rivers elsewhere, the IJC is unique for its independence from governments and politics, its powers, and its breadth. It oversees not one, but more than a dozen watersheds with hundreds of lakes and rivers. The IJC is founded on a vision and on principles. Shared waters are to be jointly managed. Studies and decisions are made by consensus among an equal number of people from each country. In each watershed, the Commission appoints boards comprised of experts from both countries representing a wide range of perspectives and knowledge. Board and advisory groups are from national, state, provincial, and local institutions, indigenous communities, and the public. Decisions are informed with facts and the best science available through specific studies and monitoring. The IJC has a responsibility and a duty to consult. So while we develop our recommendations to governments, we need to consult the public. And indeed, the timing of this event coincides with a special duty to report every 3 years to the parties on how they are progressing in achieving the goals of their Great Lakes Water Quality Agreement, first signed in 1972. A very well-attended public forum will be held in Niagara Falls next week. Your chance to go and see the falls and come to the forum. We are facing global problems requiring global dialogue and transnational institutions. As the effectiveness of institutions on a global scale is hard to measure, let me emphasize the value of all binational institutions in the Great Lakes. In the addition to the IJC, I will name the Great Lakes Commission, established in 1955, the Great Lakes Fisheries Commissions in 1956, and the Native American Fish and Wildlife Society in 1983. I also believe in the power of individuals, in the power of teams and of small groups of people, hence in the power of local governments to effect change. Canada and the US, as Tim has said, share much more than boundary waters. We share an economy. The GDP of the Great Lakes region is valued at $6 trillion a year, making it the third economy in the world, so we have the means to progress. We share cultural and societal values, democracy, the rule of law, approaches to problem solving. This is important, approaches to problem solving, first-class research and academic institutions, and more. We have no excuse for not responding successfully to the climate change challenge. So what I want to do in this second part is look at what we have observed on climate change in other watersheds and see what we can use from that. As I said, the IJC oversees watersheds from coast to coast. And I will walk you quickly through 4 watersheds. 2 in the west, the Kootenay and the St. Mary Milk. 1 in the prairies, the Souris, and 1 in the east to highlight different climate challenges along the boundary. So the Kootenay is a mountain lake, and it's replenished in early summer by melting snow fallen during winter over the surrounding mountains. The depth of the snowpack is the main predictor of the amount of water that will flow into the lake in the spring and summer. The St. Mary and Milk rivers are also mountain rivers in the sense that their source is in the mountains. They are very important to Alberta and Montana farmers, as well as to indigenous communities. They all share a relatively dry environment. So every drop of water is important. They both originate in western Montana, they cross into Canada, the St. Mary goes all the way to Hudson Bay, and the milk goes back into the US and eventually flows into the Gulf of Mexico. So this is amazing, finding those two rivers from one point a few miles distant when they originate, and they end up in, different worlds. Their sources are glaciers. And as the slide shows, something is happening to glaciers around the world. A warming climate will mean less snow, less ice, less melting glaciers, of which many will disappear entirely if the warming trend continues. What will happen when the year-round precipitation is not snow but rain? Rain does not accumulate, it runs off or percolates into the ground or into glaciers, making them even on their way to melting. And even slight changes in temperature regimes and patterns could have huge impacts on seasonal events on all of these western rivers. The Souris is a small river channel, very small. I come from the St. Lawrence River, and when I see these rivers, I wonder if they are rather brooks than rivers. I guess if you're from Michigan and you see this lake, you wonder what the other lakes should be called. This environment presents two major challenges. Two features in the upstream basin. One is the pothole topography, and the other one is extensive irrigation pipes. They call them tilings in this area, in that area. Both present real challenges for estimating water volume or flow to know how these would be affected by climate change. And there is significant evidence pointing to a high degree of natural variability in that basin. An all-time record flood occurred in 2011. It was a 250-year event. However, the operation plans for the reservoirs that are upstream in the province of Saskatchewan, Canada, had been geared for a 100-year flood. This flood was devastating, and bigger floods cannot be ruled out in the future. The last watershed I want to outline is the Lake Champlain-Richelieu River watershed. Two strikingly different systems. Upstream, south of the border, Lake Champlain is a large lake surrounded with the mountains of New York and Vermont. Its narrow outlet leads into the Richelieu River to the north, flowing over very flat land. There was a record flood also in 2011 due to the concurrence of rapid snow melt in the spring and unusual amounts of rain at the same time. Luckily, the flood triggered a multi-year study funded by both federal governments and which produced a number of groundbreaking actions and tools that will also be of use elsewhere. I will highlight three of the results and tools. Firstly, such studies in the IJC and elsewhere are traditionally of a purely hydrological nature. This one included the social, political, and economic contexts and developed a powerful integrative tool allowing for quantification of flood impacts. The second one is that on a large lake, not only lake levels, but water levels, but wind velocity and wave action can be destructive. So the study therefore funded NOAA. Sometimes they fund us, but sometimes we fund them, to produce maps that are available to all. I hope you can see there. Yes, you see that there are arrows on the last two ones. So these maps are available to all on internet and give in real time for the whole Lake Champlain, from left to right, wave height, water level, wind velocity, and surface currents. These I took, would have been 7 a.m. in Chicago on September 8 when I was preparing this presentation. So you could go on that site now and find out what are the currents and winds on Lake Champlain at this very hour. This model can be used elsewhere. I'm sure some people on Lake Michigan would love to have something like that. Ask NOAA, because I I think they are going to work on this as well. This would make a big difference for marinas, boat owners, for everybody. The third tool and result is that on Richelieu River, the study produced a dynamic model showing the exact height of water at every point in the floodplain as a flood progresses. And I'll add something here. Some of the people who participated in this teamed up or gave some of the tools to a private firm in Quebec who is now working with municipalities, even small municipalities that have a river that can flood. They relate the flow upstream. Sometimes it's a river that originates in the mountain. They can relate the flow upstream to the flood or the exact level that will occur in the village as the river crosses to a few inches of water, and telling them the flood will be of a given height on Wednesday around 9 o'clock, so they can prepare and be ready. So this map there is fine-grained. You see the middle is the channel of the river, and the rest is what was flooded in 2011. And it's fine-grained to 1 meter square, about 3 by 3 feet on the surface, and the precision of under 1 inch on your property. They give the number of properties, homes, streets, and other features impacted. Municipal authorities can know ahead of time how many sandbags will be needed in every neighborhood, alternate road access for emergency services to reach vulnerable people, and where these vulnerable people live, and other safety measures. So what have we learned from the other watersheds? And I've shown you 4 of them. The lessons learned are that climate change may alter the timing, seasonality, intensity, frequency, and duration of stream flow events. In general, the frequency and intensity of annual precipitation and of extreme events are anticipated to increase in the future. Each system will react in its own way to climate change. We need to understand challenges locally. We need to address, identify, and protect local vulnerabilities. And we have to include social, political, and economic impacts of change in addition to describing the hydrology. Section 3 is inspired by the old adage, think globally, act locally. This quote is from the executive summary of the 2021 report of the Intergovernmental Panel on Climate Change. They are, in fact, saying, in simple words, be ready for a warming of at least 3 degrees over the next 80 years or so. Why? Because if the past is indicative of the present, mitigation ambitions will likely not be realized. Of course, this is a stark warning for today's newborns and their offsprings. But I also say, how useful is it to know the exact global figure in order to project what will happen in a given watershed? That figure is a global atmospheric temperature change as average over the whole planet. What does it mean for someone who lives 50 miles south of here? The IPCC report was somewhat helpful in dividing North America into 6 very broad regions and making projections for these regions. But really, what we need is a finer knowledge of how climate change will translate into the actual hydrology of a given watershed. To answer this, experts will need more sophisticated regional hydrologic models than the ones used presently. The output of that global climate model needs to be downscaled and it needs to be bias corrected. I'm not going to go into the detail on how to do that. And in addition to temperature and precipitation, as are currently used, the new models will also require inputs for other parameters, such as incoming long wave and short wave radiation, barometric pressure, wind speed, evaporation, specific humidity. These new models would then be able to deliver information at a sub-daily timescale. I'm told 3 hours or less, which would be a very big improvement. And I'm told it can be done, and it is relatively easy to do. For projections into the future, these new models could be run for a multitude of worldwide emission scenarios. Depending on exactly which promises and ambitions have been met, we could follow what could happen in a given watershed. I get you get the gist of it. Global models are not useful for telling what will happen in your backyard. And the current regional models are limited. Not that we will be ever certain about the weather and flow over the land. There will always be uncertainty. And this is a difficult message to deliver to the public, who expect some measure of certainty from experts. And they doubt experts because they are not certain. The problem is that we have not exposed enough what we know about science to the general public. Science is not about certainty, it's about doubt. But we can focus on reducing uncertainty, and that is a message of importance. Let me now go over to the Great Lakes, present and future. In 2015, the IJC created the Great Lakes Adaptive Management Committee, or GLAM for short. Its primary mandate is the ongoing evaluation and improvement of all current regulation plans. This process will identify vulnerabilities and provide scientifically sound data and technologically advanced tools for supporting management decisions. A good example is the regulation of Lake Ontario. Now I will get into something that was a huge problem or effort for us starting in 2019. Started before that, but I wasn't there. My problem started in May 2019. In January 2017, a new regulation plan, Plan 2014, came into effect. And if you want to know the culprit, he is sitting here in this room. Murray Clayman worked on these things because he is quite an expert. And Murray was with the IJC before. He was secretary of the IJC when I was there from 95 to 98. And he's a good friend of mine. So Murray knows what I'm going to say now. Mere months after the new plan came into effect, extremely wet conditions across Lake Ontario and the St. Lawrence River caused a severe, record-breaking flood impacting all interests. 2 years later, an even worse flood returned, and levels broke the record set just 2 years earlier. Late May through the beginning of August was the worst extended period of high water since record-keeping began more than a century ago. So we were appointed as commissioners in May 2019, and they gave us boots to carry out our job. And we started going into communities who were flooded, and everybody was angry. Everybody was blaming the plan. It was to be expected that the public would conclude that 2 more than 100-year floods in 2 years was statistically impossible. Error, it was improbable, but it was possible since it occurred. So they concluded that the plan had caused the floods. However, technical reviews show that without infrastructure, the dam that's there, and the operations under the plan, the water levels would have been even higher. In reality, even though the board employed several strategies to try and balance the interests in different sectors, the fact is that no regulation of outflows can prevent flooding when supplies are so extreme. So in the fall of 2019, we mandated the GLAM to review Plan 2014 in an expedited way. So phase 1 of the review has been completed. Based on damage surveys, it produced an innovative decision support tool that provides broad-based metrics and up-close data across interest groups and geographic areas about the potential impacts of specific flow. The tool will not eliminate extreme highs or lows, nor will it make decisions for the board. It will inform the board that it better understands, so that it better understands the impacts on uncertainties of deviations options. During the pandemic, starting even before the pandemic was declared, we held a total of 30+ virtual webinars, meeting with interest groups, all interest groups, meeting with the public, meeting with politicians to try and explain how the system worked. And what was very helpful was struck a public advisory group. We brought together 18 members from all regions and interests in the basin. We selected the strongest opponents to us and to the plan, and we put them on that board, this group, public advisory group, and we said, we will spend as much time as you want with you, and we will go through everything. All the technical aspects, all the books are open. You can look at any document that was ever produced on the plan, on the regulation, why we do it, how we do it. They met every 6 weeks for almost 2 years, and they came to conclusions. The public advisory group's findings are, the system is very complex. It is not possible to prevent flooding in a given place without jeopardizing other interests, and no plan could have prevented the flooding. So we went from total catastrophe to success. And, well, half success, because then we said to those members, yet now you are our ambassadors, and you go to the public and all those who criticize the plan and the IJC and explain to them, and they said, no, we don't want to do that. We will be put aside in our communities. Nobody will. Can you imagine how difficult it is to get the public to agree on something? We have to work at that, because climate change, we will need everybody to fight climate change. So, phase 2 of the expedited review is underway. One of its main goals is to provide an analysis of possible modifications to some of the plan rules and limits and trigger levels. Personally, I don't think we will find much that we can change. This plan was studied, Marie, 12 years, was 12 years in the making, with all the expertise and all the, checking this and that and modeling. I doubt that we will find anything that will make it more efficient when nature is throwing water at us. In the fall of 2019, we started in August of 2019, we were flowing maximum flows at the dam from August to November. Then the Halloween weekend, 2019, there was a storm over Lake Ontario. It was like a tropical storm, and it put that back in the lake in 24 hours, 36 hours, all the water that we had flowed out of the system since August. Can you imagine how interesting to learn that when you wake up in the morning and you're the IJC commissioner? Yes. So one very important message here is that exposing facts and science is necessary but not sufficient as a communication strategy to sway people. As we progress toward a gradually more threatening climate, we need to bring people into the game, the equation, as a key to success. So, federal Great Lakes science programs have not undergone a major review for over 20 years. With climate impacts and other stressors, a comprehensive assessment is needed to understand and anticipate changes that will affect the Great Lakes. With that in mind, the IJC Science Advisory Board is developing the first comprehensive decadal scale science strategy for the Great Lakes. It is a collaborative process engaging the science community, resource managers, rights holders, and stakeholders via a series of actions that will include town hall meetings, online surveys, and virtual workshops to bring everybody into the picture. The Commission expects, nevertheless, that the strategy will identify science gaps and needs and establish a roadmap for placing the management and sustainability of the Great Lakes on a sound scientific footing. Science today has numerous new tools to unlock questions and gaps in our knowledge. So science plans that are more than 10 years old may not be that potent compared to what we could do today. And these tools will likely evidence vulnerabilities to users and to human communities. As I was writing this, I saw that I've been referring exclusively so far to surface water, and I need to say a few words on groundwater, the water that is present beneath the Earth's surface. You may be more familiar with the word aquifer, which actually means a container, a unit of rock or a deposit that contains the water that you want to get at. About 30% of all readily available fresh water in the world is groundwater. The IJC Science Advisory Board in the 2018 report emphasized the importance of groundwater in the Great Lakes and that we lack the tools and the model for monitoring it. We know that groundwater is recharged from the surface, and there is a more or less continuous exchange between the two. And groundwater is often cheaper to obtain and less vulnerable to pollution, so it's commonly used for public water supplies. In fact, it provides the largest source of usable water in the United States. And of all the states, California annually withdraws the largest amount of groundwater. So groundwater flows directly into the Great Lakes from rocks and glacial sediment, and indirectly via rivers and streams. If it's contaminated by land use activities, it can impact drinking water. And in addition, the exchanges are not well understood, and the potential for drought and flood conditions can be estimated more accurately if we knew more about groundwater as climate change plays out. And only a few weeks ago, it was wonderful for me to read on the Michigan University website that their researchers were granted almost $1 billion from the National Science Foundation to develop a model monitoring surface and groundwater flow to help predict seasonal changes in the Great Lakes Basin. Our Great Lakes Science Advisory Board, in another report in 2020, found that in most cases, a warming climate has already interacted synergistically with existing stressors. This means that a number of stressors, the combined impact from a number of stressors is greater than the sum of the individual stressor impacts. This slide gives an example of how a changing climate worsens impacts from phosphorus loading. Storm events will cause soil erosion, increasing the leaching from the land. And in a warmer lake, you can have larger blooms, which, when they die off and are degraded by microbia, deplete the oxygen, creating dead zones. And for some reason that is not well explained, when you have a dead zone, phosphorus that is already in the sediment is released. So that encourages the chain of production of blooms. I will now move to water levels in the Great Lakes. I think this is an extremely important subject. Lots of information here. It shows monthly mean levels over 100 years for each of the 5 Great Lakes, and including with also Lake Sinclair, which is not really that great a lake. There is a lot of information here, but I will point out the following. The red lines are the average. Of course, the blue lines, which actually show the monthly mean level from 1918 to 2022. I had a previous one, but I had this one put on. So this is the latest data. So there's a lot of wiggling in those blue lines that are due to seasonal changes. You know, the lakes are usually highest into the summer and lowest into the fall, although Lately, we've found that sometimes they remain pretty high. Lake Erie has been high for 2 or 3 years. But it is also obvious that there are relatively large year-to-year variations around the average. This seems to be the norm for the Great Lakes, not only recently, but it's always been like that. If you look back in 1916 or 21 or 24, nobody was talking about climate change then, and the lakes were varying. Actually, the biggest flood on the Mississippi was in 1926 or 27. Who talked about climate change then? So there was a huge event that happened there, which may not be directly to a trend, related to a trend, but these are all things that we have to understand. The lakes are certainly not static. If you look at the second graph, which is Lake Michigan-Huron, we say Michigan-Huron because those two lakes are connected, so they're one lake in reality, which makes that one lake bigger than Lake Superior in terms of its area. So this larger lake is arguably the most variable, if you look compared with the others. So it's not because it's large that it's resilient. Things are happening. Water can fall from the sky and change a huge lake like this one. If we move to the right, to the 99, that's 1999. For 14 years, the lake, this is unusual, it was below average for 14 years. And then suddenly, starting here, it reached in 2013 its lowest level ever, a record year. And then it shot up. It went up, and within 7 years, I think, it rose to its ever highest level. So this is the movement of an almost unimaginable amount of water. Next one. This shows the precipitation over the basin since 1895. Here the points are 3 years. Each point represents lumping 3 years together. If you look again at the extreme right, it is clear that the rise of Michigan-Huron to record high in 2020 was a response to an unusual amount of precipitation, above anything that had ever been seen before. And the blue line evidence a consistent trend upward over more than a century. This, I think, the conclusion to this, it's obvious, regulation is not the solution. There are only 2 points where we can regulate, quote unquote. One is downstream of the Great Lakes, about halfway between Montreal and Lake Ontario, the Moses Saunders Dam, which is a large dam that can flow up to 11,000 cubic meters per second. And the other control point is on the St. Mary's River, which is a much smaller capacity. The IJC carried out a study in the 1990s, and because of constraints on the structures and on the channels, these 2 control points cannot regulate Great Lakes level unless they are not too far from the average. A multi-year study in the 90s showed that building additional control points, for example on the St. Clair River, would not only be extremely costly, but would simply pass the buck and create major issues downstream into Lake Erie, Lake Ontario, and the St. Lawrence. The study concluded that floodplain management and land use strategies, including building codes, offered the best solution for protecting riparians. In the Lake Ontario, St. Lawrence River system, Quebec and New York State are taking starkly different approaches to abating flood risk. Quebec officials have encouraged flooded property owners to take buyouts and thus break the cycle of flood, bailout, rebuild, repeat. New Jersey responded in the same way after Hurricane Sandy. On the contrary, New York State has encouraged Lake Ontario property owners to armor their shorelines and hunker down. These shorelines will have to be rebuilt in a number of years. That is almost certain. Now, after I've said there's a lot of uncertainty and we can't predict the future, I'll have a go at it. Various models can be used to look into the future of the Great Lakes under climate change. I show here as an example to show you what can be done. The projections modeled by Frank Sigliniak's team at the National Hydrological Service of Canada. Observing recent trends of higher temperatures, evaporation, and precipitation, Frank modeled into the year 2100 to see whether these trends would hold. So the slides may be a bit confusing there. There are lots of lines and things happening, but let me highlight salient points. All lines are annual levels over the period 1950 to 2100. So the first 50 years, the black line is actual data. This is what was observed. And the rest is, we're trying to compare the rest to what was observed. All colored lines are future projections. Anything in blue assumes some mitigation of emissions. We call that the trend RCP 4.5. It means society in general, the world decided to adopt some constraints, real ones, on emissions for the future, and that the blue lines show what that would do to the Great Lakes. Modest reductions. The red lines are business as usual, no control of emissions, we just go. And we see that in both cases we have large variations, more extreme highs, more extreme lows, but with the no emissions control at all, we get some extremely high levels by the end of the century. So this is only a modeling. It's not the truth, but the more we try and come up with better models, the climate science will improve in the years to come and modeling will improve. So Frank's findings are the patterns observed in the Great Lakes will continue, so don't expect the lakes to be quiet and stable. Lake levels to increase in variability with more extreme highs and more extreme lows. The most extreme changes occur under higher emissions scenarios, which makes sense. And actual changes will depend on how society acts and how the atmosphere responds. Just a few words because we are in Chicago. There's another phenomenon that will influence, but in a smaller way, water levels in the Chicago area. It's called Isostastic Rebound. After the continental glaciers started melting about 10,000 years ago, the continent slowly relieved of all that weight. And I don't know about here, but where I lived as a kid by the St. Lawrence, there was something like more than a mile of ice on top of what we see now as mountains. That is a lot of weight. So the continent rebounded slowly. And in some areas, it's like you put weight and, you put weight and the continent is like this, and then you release the weight, it goes like this. Some parts will go down and some parts will go up. Nova Scotia, for example, is subsiding. Well, on the Great Lakes, the north of Lake Huron, Georgian Bay, will be rising slowly, but at this end, the Chicago area will be subsiding. So you may not notice it, by the time we get to the year 2050 or 2060, but it's estimated that it will go down by 4 centimeters by the end of the century. If there's a meter or more of water on the lake, you won't notice. But this will affect the lake irrespective of climate change. So it's not 4 centimeters, 4 inches higher today than it will be 4 inches. The water will be 4 inches higher today in 2100 than it is today at Navy Pier, for example. I'm coming to the last part of my talk, I think, adaptation. Living with water. I will outline some challenges and adaptive behaviors that are in that those broad categories there. Climate change, of course, will not only change hydrology, but and ecosystems, it will change society profoundly. Fighting climate change without considering social aspects and impacts on communities and the more vulnerable is doomed to fail. It is imperative to consider a variety of parameters that directly affect citizens, communities, and cities in the Great Lakes. To name only two: land use policies, water supply and quality in the face of fluctuating lake levels. And I see here a very special role for cities. I am thinking in particular of the St. Lawrence and Great Lakes Cities Initiative. The last time I looked, there were 175 cities who were members of that initiative. This is a binational initiative in a good position to be among the leaders to prepare their citizens for climate change. We all need to think from a more transformative standpoint of how society should be structured and where we should live and how we should live. Human health will be affected as well. One of the IJC's advisory bodies is the Health Professionals Advisory Board. They have welcomed the concept adopted in 2021 by the World Health Organization, the One Health system. This is an integrated, unifying approach that aims to balance and optimize the health of people, animals, and ecosystems. It recognizes that the health of humans, domestic and wild animals, plants, and the wider environment, including ecosystems, are closely linked and interdependent. Humans depend upon the services provided by nature, and unless we effectively account for the range of values from ecosystems in our efforts to face climate change, we will not be able to sustain human well-being. Climate change will impact human health directly in other ways. One of the very first studies carried out by the IJC was on waterborne pathogens at the first quarter of the previous century. Waterborne pathogens in the Great Lakes. It led to a revolution on water treatment, both before and after using it and returning it to the environment. With the changing climate, it is estimated that heavy precipitation will worsen the situation affecting the drinking water supply of 40 million people. Another threat, of course, will be invasive species, and notably those carrying plant, animal, or human disease vectors, such as mosquitoes. Adaptation versus mitigation. I think there's a confusion on which is which. Another threat will occur from the fact that we don't recognize the difference between the two. Most studies have emphasized mitigation, the psychology behind individual coping strategies in the face of a flood for a single household. The symbol of that basic response is to move valuables to higher ground, so to speak, and let insurance resolve problems and governments as they arise. As I said earlier, that, as much as building walls, is mitigation. We require adaptation, which covers measures at a higher level. We have to be thinking about what is truly adaptive for society and understand the dynamics that lead people to accept and adopt new systems through transformational actions, and barriers that keep people from embracing transformative efforts. Current plans barely mention adaptation, which would examine whether a coastal community should exist at all where it is presently, not building walls so that people can survive there, and how to plan a coordinated movement, a managed retreat, if you want, away from coastlines and other vulnerable areas. We avoid studying adaptation for fear it would redirect attention and efforts away from mitigation. Mitigation is for now. Now that the flood is on your property, you do something to mitigate. Adaptation is for tomorrow, for the future. We have to do both. and to avoid the really catastrophic outcomes that will come down the road. Working with nature is a step-by-step approach. As we assess hazard risk, community vulnerability, and social values, we need to identify nature-based solutions, take conservation and restoration actions, measure the effectiveness of these actions at reducing risk. We need also to communicate and outreach at all stages during the investigation, design, and construction phases. It also includes rewarding people who are using natural solutions for protecting and enhancing wetlands, shorelines, whatever ecosystem is useful. A study at the University of Texas in Austin showed how remedial actions not only rehabilitate natural systems, but contribute to fighting climate change, thus providing added economic benefits. For example, preventing lakes from aging, which we call eutrophication in ecosystem ecology, from aging through excessive plant growth reduces the amount of greenhouse gas methane released into the atmosphere. The study I mentioned estimated that through 2015 to 2050, damages avoided could run to $24 trillion. We have time to adapt if we focus on deliberative and thoughtful approaches. The major impacts will occur over decades and into the next century, but we can and we must get started now if we want to prevent overwhelming impacts. Reaching the necessary emissions cuts to keep warming near 2 degrees from pre-industrial levels will require an all-out effort, one that will fail unless all sectors, including food manufacturers and farming, become part of the solution. A recent report from University of Oxford researchers, published in the journal Science, found that the food system alone will generate enough emissions to blow beyond the so-called more ambitious 1.5 degree target of the Paris Climate Accord within 4 decades. The last issue I want to address is the migration risk. This is an issue that has been in the news nowadays, migration, but the one I'm talking about is the one triggered by climate change. And I'm not referring to immigration from other countries. I'm referring to migration within. Our Great Lakes Science Advisory Board included this concern in their science strategy project. The prolonged and dramatic drought in the south and west has brought back to life proposals to divert water from the Great Lakes. The pressure for exporting water will only increase with climate change. But something else will also be evolving. Water is forbidden. If we prevent water from being exported, then the activities that need the water and the people who depend on them will travel north. We don't always understand who the biggest users are. We naturally think of cities in what looks like a desert to us in the south, like Phoenix or Las Vegas. But the biggest user by far down south, is agriculture. It uses 80% of the available water. Using the Colorado River as an example, in the news, the federal government is suggesting rather drastic cuts, maybe up to 40% of the recent flow. In the past, to compensate for those cuts, which happened in the past, users have resorted to pumping groundwater. This has only accelerated the depletion of aquifers. The Great Lakes, with its supply of fresh water, a temperate climate, the expectation with climate change that the growth season will be extended, it may become a climate refuge. In this context, a better understanding of the system is paramount for avoiding catastrophic shocks and their associated social, environmental, and economic impacts, and to prepare for population growth from pressures that are presently poorly defined. I'll be wrapping up. I have drawn attention to the relevance of the IJC's work to facing climate change, to the government's increasing attention to it, to bringing the public to accept the reality of the phenomenon and the need of a coordinated response. The IJC, as a binational institution, offers a forum where our boards of regional experts are regional and organizational linkages to the public and to indigenous peoples, using the way in which we defer to science and facts and communicate them. We can help formulate a necessary binational response to climate change imperatives. Thank you. Yes, I'm 5 minutes late. Is it okay? Yeah. Only 10 minutes for questions as opposed to 15? Yes.
Thank you for the nice presentation. The last point you raised, the migration risk. And for the U.S. population, it makes a lot of sense, the Great Lakes being a climate refuge. What do you see happening in Canada? Because the move north here makes sense. There's infrastructure already.
Yeah.
Do you see a lot of development happening in Canada's north, where none exists now?
I think it will happen in the U.S. elsewhere than the Great Lakes as well, like California moving north to Oregon maybe, and Washington State, because there's no water down there, they can move up. The activities and the people who carry out the activities. In Canada, it will likely occur as well, but not to the same degree, unless the border becomes like a sieve. I think there's only 30 million plus people in Canada, and there's a lot of room. I have not studied because rarity of water in Canada is not as evident as in the southwest, but in Alberta, the Souris River, was it in 2020, during the pandemic, the St. Mary River that I mentioned, there was an engineering feat that was done back in the 1920s. They transferred some of the water of the St. Mary's into the Milk River through a kind of suction system that goes over the divide and then flows. I visited that. It's just incredibly clever. But back in 2020, two of the structures that allow this just were destroyed. Too much water, or they were too old, or whatever. So we were faced with communities on the Milk River on the U.S. side who were running out of water. So we worked very hard with the state of Montana, the province of Alberta, and Saskatchewan, and the two federal governments, and we got the thing fixed by October, which is just unheard of. We went through the red tape. We got the concrete needed. There was no road from Montana to go into those areas, but there were tracks from Canada. So the concrete came from Canada, crossing the border during the pandemic, and people were looking the other way, and they crossed and they fixed it. So this shows, I was talking with Tim, how we can collaborate the two countries. So the west in Canada is drier. The east is not dry. We don't expect it to become drier. But yes, people could move from the west, Canadian west, to the east, even though there was a movement the other way during the 20s and 30s and into even the 60s. People were moving from the east to the west. But yes, there will be migration of people in the drier parts of Canada, of course. Yes.
Thanks for your presentation. My question, you mentioned several times in your presentation the need for social change to sort of drive on what you're talking about. At least on the U.S. side, it seems like a lot of the Great Lakes policy work, it really drives towards very traditional ecological outcomes and doesn't really connect those, in my opinion, very well to some of the social outcomes that are part of this work. And so you talked, when we talk about climate change, coastal management, drinking water management, I find that part of the conversation is often absent, and it's absent in some of the goals, these sort of purely traditional ecological goals. How do you get at that? What policy changes or what goal changes are needed to actually bring some of those social outcome conversations into this ecosystem discussion that's been going on in the Great Lakes for 5 decades plus?
I think this is a very important question, but unfortunately, I'm not a social scientist. I only know by experience that you have to involve the public into anything you want to do these days, more than ever. And social change means that the majority of people agree to move to something else. And getting a majority on issues that are as acute as fighting the floods or fighting this or fighting that is not easy. It's never going to be easy. And as I said, we were happy to have put together this public advisory group, bringing in our strongest opponents, and they were convinced, but they don't want to go to talk to the rest of the people because they are in this antagonic confrontation, If they're looking for someone who is responsible for the flooding, as opposed to accepting a change in their lives, in their way. I was on Fox News this morning to talk about this conference, and they asked me, okay, what can people do? The problem is too big. I said, I know I'm not answering your question, but I cannot because I don't know the answer. But I said, people think that climate change is a huge problem. It is. But then they say, well, we can't do anything. It's too big. But you break it down into pieces, into blocks. There is not one solution for everything. There are specific solutions for specific items within that big problem. And if you try and address them, and if you interest people in their own lives, the host said, so what should I be as an individual? I said, well, find something that you believe in and that for you would be important. For example, you could say, okay, I'm going to use my car less. Another one will say, well, I'm going to change my diet, because changing one's diet improves a lot. As I said, agriculture is responsible for a very high percentage of emissions, and some foods, producing some foods, are more damaging to the atmosphere than other foods. And I said something, and then when I walked out, I said, my God, I'm in Chicago, and I said that. I said, you could eat less beef. It didn't strike me there, but on the sidewalk, I said, my God, people are going to look at me. This guy said, at least, eat less beef. But if it's your thing, you can do it. Someone else will do something else. And we have to empower people that as individuals, they can make a change. Because the history of humanity is individuals who have changed things. And science is the same thing. It's someone who has an idea one day, and he works at it, and he changes, not immediately because people react negatively. Scientists are humans, Galileo, he had to, in 1616, the Pope and the cardinals said, no, you're no longer in the Catholic religion. He said, yes, okay, I agree. But the earth will keep turning around the sun, nevertheless. So individuals change lives. And we have to believe that we are individuals and we have some power. We can do something. And this is a major challenge.
Do you think that there's greater acceptance of that the climate is changing, given the evidence around the Great
Well, the guy, I don't know, I shouldn't say that, but the host at Fox News said yes. And I thought that was a big, movement forward. No, I'm joking, but I think people now are scared. And being scared is not ideal, because when you're scared, you do the wrong thing. You run away, or you don't want to look. People have to be confident that we can do something. And it starts with the individual. And it starts, I said something about the Great Lakes Cities Initiative, because I think municipalities can do a lot to change the way we live, because we live in cities. We don't live, in some imaginary world where the big controls are. We live in cities, day-to-day things we do. And I think if we can empower people to change that. Another thing we have to work at, and Tim mentioned it, is we have to work on social injustice. Because social injustice can grow. It's a bit like we have to work also on. As a scientist, I used to think that knowledge is empowering because you know things, you can explain things, and that ignorance had no power at all. But since 2016, I've changed my mind. Ignorance is very powerful. It self-perpetuates. You don't have to do anything to live as an ignorant. You don't have to study. You don't have to take time to understand. All you say is you affirm your ignorance, and you gather people around you. And this is a force that we have to fight against. So it's not good to say, I have knowledge, I'm a scientist, and I know how things are working. I don't know the answer to this person there. We just asked about social change, but, and you can try and avoid talking to people who don't understand what you understand, but you won't get anywhere with that. You have to bring everybody in. Thank you.